你好，我是李林瑞, or my English name is Lam Kim Long, and my student ID is F1142002. And this is my final project. My final project is about a global COVID-19 update report, a country by country and analysis of data and trends. And I will walk you through the chapters. We have like 6 chapters. 1 is introduction, 2 is SQL table creation and processing, 3 is analyze the data using Python methods, and 4 is visualization and analysis using Grafana, and 5 is I will add the data into MongoDB, and then 6 will be my conclusion. We will go into the chapter 1, introduction. In here, I use the COVID-19 dataset, and this is the data about the global COVID-19 situation by countries using the last updates, such as total case, deaths, recoveries, and trends over the past weeks. And objectives is to identify the most effective areas, assess the effectiveness of epidemic control, and visualize the data to support the public health decisions. And you can see this is the data I use, and you can see it in Kaggle because I take it from there. And I will walk you through real quick about the dataset information. One is, I told you that the data come from Kaggle, and summarizes this is the snapshot dataset recording the final update status for 187 countries or regions. Includes the key metrics like confirm rate, death, recovery rate, and active case. A case feature is pre-calculated data for 1 week trends and classification by WHO region, which directly supports our analysis of objectives. And you can look at the table here in the right. It will have the column names and the description. And country regions is stand for country or territory name. And confirmed rate is total COVID-19 confirmed cases. Death is total death. Recovery rate also like that is total recovered cases. Active is number of active cases. Confirmed rate, deaths or recovery. And new cases is number of infections of the most recent day. New deaths is number of new deaths in the most recent day. New recovery is news recoveries in the most recent day. Deaths per 100 cases is death rate per 100 cases. Also the same for recovery and death. And confirmed rate last week is number of confirmed cases last week. 1 week change is the difference in cases compared to the last week. 1 week percentage of increase in case in 1 week. WHO region is WHO region. And we will come into the SQL table creation and processing. In this part, I use the SQL-based analysis to explore the COVID-19 case trends, including computing global and region statistics, identifying the highest countries, and using those and store the procedures to automate the key insights. And I will have total 9 tasks, and I will do like a table here for you to see is my analysis step is. Task 1 is I will display the first 10 rows for the data table. Purpose to get an additional look of the dataset and check the data format and consistency. Analysis task is I will calculate the total number of deaths across all countries. Purpose is to understand the global impact of COVID-19 in terms of mortality. 3 is computing the average number of confirmed cases by WHO region. Purpose is to compare the severity of pandemic across different regions. 4 is to identify the top 10 countries with highest death rates per 100 confirmed cases. 5 is list of countries with a growth rate higher than 20% in last week. 6 is sum of the active cases per WHO region. 7 is create a view of high-risk country based on that rate. And 8 is you will store procedures to summarize country counts and total cases by whole region. 9 is use a parameterized store procedure to filter countries with high case counts. And each part, I will get my conclusion and the insights in the chart or in the dashboard. And this is on the table that I mentioned to you in the first table about the task I do and the purpose I do here. And this is the sample of first 10 rows in the dataset. You can see here we have Pakistan, Albania, Bulgaria, Australia, and it belongs to the WHO region is Eastern Europe, Africa, and Americas like that. And here you can see in the left there will be total of deaths across all countries. Now it's like 654,036 cases death global. And this is the average confirmed case by WHO region. And top 10 countries with highest death rate 100 cases. You can see such as in United Kingdom the rate is about 15.19. Italy is 14.26. And you can see all the countries, top 10 countries. This is the top 10 country, meaning the highest top 10. And the next one is country with more than 20% weekly growth rate. You can see at the first is Papua New Guinea, and it's like 200% increase. And then next is the total active COVID-19 cases by whole region. And you can see this is the top 6. And next one is the high-risk country, means the death rate bigger than 5%. And you can view the result. This is the summary by WH region using STOR procedure. And the next one is country with more than 1 million cases procedure with parameter. And in this step, we imported the clinic COVID-19 dataset into SQL Server as a structured table. The table includes key clues such as confirmed case, death, recovered patients, and whole region. Several later processing queries were designed to aggregate the number of cases, calculated death and recovered rates, and identify the country with sharp, quickly increases. These SQL operations have transformed raw tabular data because the first time I used the Excel file and then I import it into the SQL Server. So I transform it from the Excel into the table format, and then data from raw, the Excel format, turn into the insight that support further visualizations and comparisons. And the first part is analyze the data using Python. And I will also have, in this session, I will analyze the data using Python and descriptive statistics, filter and group data by regions, by type, and visualize the result using bar charts, pie charts, histograms, and a heap map to uncover key patterns and correlations. And I will have total in here these 6 tasks. One is show top 10 country with the highest number of deaths. 2 is filter country with quickly growth rates bigger than 20%. Visualize the distributions of countries by whole region. 4 is show top 10 country with the highest confirmed cases. 5 is visualize the active case distributions by whole region using pie chart. And 6 is the last one is to create a heat map of key numeric feature. And the purpose you can see it here. I will step into this and look at the first one, the blue one. You can see the top 10 country by total deaths, and US is the top of it. Next is Brazil, United Kingdom, Mexico, Italy, India, France, Spain, Peru, or Iran. And then the next one is country with high weekly case growth. And you can see at the top is Papua New Guinea, and then Gambia. And then the next one is number of country by whole region pie chart. And you can see the percent, each part is combined into this chart. And the biggest is Europe, Africa, and then Americas, Eastern, and then Western, and then Southeast Asia. And then you look at the chart in the right, will be the top 10 country by confirming COVID-19 cases. And the lead one is US, Brazil, India, Russia, South Africa, Mexico, Peru, Chile, UK, and Iran. And this is also the pie chart of global COVID-19 deaths. And this is Americas, Europe, Southeast, and Africa, Eastern, and Western Pacific. And then you can look at the heat map to see the correlation between on the attributes in this data set, the correlation in the COVID-19. And this have a lot of type that correlation. You can see the bar in here is really from -1 to 1. As you can see here is the charts above provide a deeper insight into the COVID-19 data. A bar chart and the pie charts highlight the regions and countries with the most active or confirmed cases. The plus bars show how recover differ by whole region, and the heat map reveals strong correlations between confirmed case, death, and active patients. And the far part is I will visualizes and analyzes using Grafana. All the charts created by connecting the Grafana directly into the SQL Server using the query developed in the session 1. These visualizations have highlight key trends such as recent case distributions country with high weekly growth and fatality rates enable clearer insights into the global pandemic situation. And you can look at here, this is the total number of deaths and first 10 record in the table. This is the total active case by whole region. And you can see Americas is in the top one. Next to is Europe. Next one is Southeast Asia, Africa, and then Eastern Mediterranean and the Western Pacific. And also in the same like Python, we can see the country with growth rates in the past week. And then this is the top 10 country with high death rate per 100 case. Yemen is in the top one. Next here is UK. This is the average case by whole region. And you can see this one is also Americas. And the section 5, I will use the data and then I import it into the MongoDB. Then I will perform the equivalent query using the MongoDB shell to analyze the key statistics such as total deaths, average confirmed case by region, and then country with the highlight fertility rates for weekly rows. You can see this is the picture I used in the MongoDB. I will have the sample of first 10 rows in the dataset and the total number of that across all countries. And this is the first one is the average confirmed case by WH region. Next one is top 10 country with high death rates per 100 case. And the next one is country with more than 20% weekly growth rates. And this is the total active COVID-19 cases by whole region. And I have this table is about the difference between SQL and MongoDB to make the comparison. The aspect is about the model table, model, data model. The SQL Server is relational, and the MongoDB is the unstructured data. This can use for unstructured, have structure, and then unstructured. And then aspect the schema. In SQL Server is strict and refined schema, but in MongoDB is flexible and schemaless. And the query language in SQL Server is SQL, and MongoDB is JavaScript. The syntax is abbreviations by line. And then the data flexibility in SQL Server is low because it's new schema and the change have to meet the requirement of migration. And the MongoDB is high because the field can vary per document. Aspect the best use case is if you want the structured data to do the report or like build the table, you should use SQL Server because it's structured data and complex joins and very strict constraint. So your data like will be have connection with each other. And then the MongoDB is if you want to flexible and use scalability and rapid prototype. And then the scalability, the SQL Server is vertical, scale up, and the MongoDB is horizontal, scale via shading. And I will start to the final session is conclusion. Work through our charge and then table and then data and then the conclusion per charge. We can see those inside is I have used the based on the analysis using SQL Server, Python, Grafana, MongoDB, and the dataset is reveals a lot of insights of the global spread and impact of the COVID-19. The regions such as Americas and Europe bear the highest case loads, while countries like Yemen and UK have notably high fertility rates. And weekly rows analysis also uncovers emerging hotspots, especially in the under-resourced country. Using multiple tools allow us to cross-validate results, gain flexibility in data explorations, and better understanding how different technology can serve analytical needs. In conclusion, the structured one, SQL, and the semi-structured, NoSQL, JSON, stand for SQL Server and MongoDB, data model will play important roles in the data-driven decisions. Thank you for listening.